So our problem is on the Stokes Theorem, which says that if we do a single integral of f dot dr is equal to the double integral across some surface of grad crossed with f dotted with the normal vector times some d sigma. And the question that we were asked to solve, we are solving with s equal to some cylinder x squared plus y squared. X squared plus y squared equals a squared. And z is between 0 and h. And then the top of the cylinder is just going to be a circle. X plus y squared is less than or equal to a squared. And z equal to h. So we're going to, the problem states using f equal to negative y I hat plus x j hat plus x squared k hat. So we are supposed to use Stokes Theorem to find the flux for this equation, especially because we're using a circle with two terms. We figured it would be better to use the left side of Stokes Theorem and use the parameterization of r is equal to a cosine of theta I hat plus a sine of theta j hat. Using that because that is just the simple polar coordinates substitutions using r equals a because of the top of the circle.
And so the next part we want to look at is we want to take the derivative, find dr. We're going to take the derivative of our parameterization, which will be negative a sine, no? Yes, right. And then plus a cosine of k hat. And so with this, now we have both components of our equation that we want to use from Stokes Theorem. And so now we're going to apply that. And so our f with, I guess our f rewritten in terms of a and sine theta, we would have negative sine theta, because y equals a sine theta I hat plus a cosine theta j hat plus a squared cosine squared theta j hat. And so we're going to use that to dot that with our dr. So we're going to take the integral from 0 to 2 pi of, we're going to not do that yet. So we're going to dot f and dr first. And so we're going to dot those together. And so that will be a squared sine squared theta plus a squared cosine squared theta plus 0. So from this, you can factor out an a squared. So you'll have sine squared theta plus cosine squared theta, which would then get you to a squared. So your f dotted with dr equals a squared.
So now we're just going to take the integral of 0 to 2 pi, because we're using the full circle, of a squared d theta, which is a straightforward centered integral. We have a squared theta from 0 to 2 pi, which just becomes 2 pi a squared. And that is it.